Section 10.5 connected particles. We'll start with the example 11. Two particle P and Q, mass 5 kg and 3 kg. So this is P and Q. Two particle 5 and 3. Square. Connected by light intensity. Connected by light. It's light. No weight. No mass. Or mass is regardless. Inextensible. It means if it is pulled by some, see this is pulling, and then if we have a 2 ms minus acceleration, so this also get 2 ms minus 1 because this line is inextensible, the string. So P is pulled by 40 Newton. So then this is 40 Newton, and as a result there should be a tension, let's say both sides, along the rough horizontal plane. So it kept in a rough horizontal plane. It means it has 2g, and this is going to be r, and this is again 5g, and there should be another let's say r1 and r2, and there is a, so this is a rough surface. Because of that there is a frictional force. On P it is 10 Newton, and on Q it is 6 Newton. So this is the setup. So this is P and this is Q, and this is pulled by 40 Newton, and this is 5 kg. Because of that it has a weight 5 Newton, sorry 5g, and so this one touch with the surface. Because of that we get frictional force R2, and this is 3 kg. So it touched with this surface. So because of that we get the normal force. This is R2, this is R1 normal force, and since this is rough plane, so it has a friction force of 10 Newton to this one, and this is also, it has a 10 Newton, 6 Newton to this one, as, and this is T tension because this is pulled by 40, and for there is a R1 to the surface and R2 to the surface, which we disregard. So we don't need this what we call, so we only consider this setup basically. So we don't need a plane. Even if we have this plane, we don't consider for the calculation. So this is let's say touch on this one, and so on surface we have R1 and R2. We don't bother about the surface. We only bother about this two particle on the system and the system. Why this is R1 and R2 two different? Because that weight is different. Now we are going to work with F equal ma equation. When you look at this system, you can see that R1, R2 and T are the unknowns. So we need to find R1 and R2. So we have three ways of apply F equal ma to this system. One is we have considered this particle, and we can consider then this particle, or we can consider whole system together. So we'll look at all the options. First of all, I'll consider Q particle. Consider Q particle. So F equal ma, when we put a Q particle, we can see that this is pulled 440 in this direction. So this is the system is moving to this direction. So I'll like to put F equal ma to Q to this direction because of that. So I can see that this is T. So on Q there are two horizontal forces T and 6N, plus T and minus 6. Or you can, this is also write minus 6 plus T. So but I rather start with this one. T minus 6 is opposite direction. 6 equal M, we know that is 3 times A. So that is one equation. Now F equal ma, I can put to this direction. Now T, there are two forces. So R1 is positive and 3G is negative, and weight we know, and this system is only accelerate to this side, not fly. It's not flying nor sinking. Because of that, the vertical acceleration is 0. So this is the second equation. Now it is clear that you can simply find R1 equal 3G. So when we found out one unknown, then the second option is consider P particle. So same way, if we equal ma to this direction, so I can see 40 here, then negative 10 equal, that is m is 5, and it has the same acceleration, it has to be A. So, and one more thing, I missed this one, T. This force, there are three forces, 1, 2, 3, I miss one. 40 minus 10 and minus T equal M, now 5 times A. So this is the third one. And the fourth one, F equal ma to horizontal for this setup. Then we can see that the two forces there, R2 minus 5G, because it is negative, M is 5 times, there is no acceleration up or downward, so it is 0. This is the fourth equation. So R2 equal 5G. Now R1 and R2 done. Now we need to find T and A. According that, those are the question. So this is 40 minus 3, 30 minus T equal 5A. So I'll name that is as 3, the simplified one. T is T minus 6 is 3A. 30 minus T equal 5A. This is 1 and this is 3. 1 plus 3. So this is cancel out, T to T. Then 30 minus 6 equal 3A plus 5A. So which is 8A. So 30 minus 6, 24 equal 8a. Divide by both side 8. So a equal 3 ms minus 2. Then from 1 t equals 6 plus 3a. 6 plus 3 times a also 3. So 9 plus 6, 15 Newton. So we found out tension is 15. So now let's consider whole system. How do we consider whole system and what kind of equation we will get? So when we consider whole system, this t is not going to come because this is going to be plus t and negative t cancel out. If we put f equal ma to this direction, this is become negative t and this is become positive c, this is cancel out. So because of that, when you consider whole system, we disregard this t. If we do f equal to this direction, it's still same. This is become negative, this is become positive, it still cancel out. Now when you consider whole system, so basically you have this one, no t, so R1, R2, this is 40 Newton, this is 10 Newton, and this is 6 Newton, and this is mg, and this is mg. Sorry, this is 2g, 3g, and this is 5g. So then forces. How many forces there? For this direction, 40 is there. Any other forces to this direction? No. Then to this direction, there are two. One is 6 Newton, another. So minus 6 and minus 10 equal. Now what is the weight M? Now you have to consider total weight. That is 3 plus 5. This is 3 and this is 5. So 8. And the acceleration is to this direction. Let's say A. So then 40 minus 6 minus 10. This is 24 equal 8A. So A equal 24 divided by 8, which is 3. So A equal 3 ms minus 2. Assume in this sum, if they ask only find the acceleration, then you should not consider separately. You should consider whole system and you can find f equal ma and you can get the acceleration. And it is clear that if I rework this 30 mean 40 minus 10, if I leave as it is, you can see that this is same as this one. When you add those two together, you will get this. Sorry, this is not, yeah, that's fine. 3 plus. So a person, for this sum, a person can work out either this one and this one, and we can work like this, or the other option is you straight away go to this one and you found acceleration. You can find the acceleration. Then you can consider only one particle, and then you will get equation with t, and you can find the t minus 3, t minus 6 equal actually this one. T minus 6 is 3a. Then you know already found a, then you can find t. So that is another approach. Either work to with and simplify, or straight away you can go to this one and then consider whole system and find the acceleration straight, and then you write a equation to obtain t by consider either this one or this one, and then with t you can find the with this equation you can find the tension. Also you can put F equal ma to both system, then you will get R1 plus R2 equal M1G, sorry, 5G, so this is 3G minus 3G minus 5G equal, it is not moving, so the total is 3 plus 5, 8. 3 plus 5, 8. Here also 3 plus 5, 8. Total weight times A. So A value is 0 here. So this A is upwardly. So then you will get R1 plus R2 equal 3G plus 5G. Basically R1 plus R2 equal 8G. But instead of finding R1 and R2 separately, if we want, you can write this equation R1 plus R2 8G. Then you consider 1. Then you found out R1 equals 3G. Then when you substitute R equal 3G, you can find R2 equal 8G. But this is a bit lengthy. You can straight, when you put F equal MA to upward separately, you can find R1 and R2. In this situation, which situation? Assume that this system is like this. So one is here, that 3 kg, and go through a pulley, and other one is here, 5 kg. So total tension are same. This is 5G, this is 3G, and you have R, and you have, if it is a rough space, you have a friction force. That's FR friction, and this is tension T and T. This is hanging, this is 5G, and now you can't consider whole system. Now you have to work separately, this one and this one. So if we equal MA to this system and then this system. So part C of this example is explain how the modeling assumption that string is light and insensible being used. So the inextensible mean acceleration of mass is same. Inextensible mean acceleration of mass is same, and light mean tension is same throughout the length of the string, and mass is disregarded. So those are the assumptions. Let's discuss example number 12. A light scale fan is attached to a vertical light extensible string. So this is a scale. So it has mg. No, it has not mg because they said that it is light. Then we have to delete this weight of this scale is attached to a light. Now you know light inextensible string. So let's say this is the ceiling. I'll just add that part. So then I should have a T and T like this. Then there's a two weights. One is 600 grams. Another one is 400 grams. Attached mass on it. So I'll expand this one and draw to show you how the forces work. So this is the scale. So I'm going to give a small gap in between those two, and this is the other one. So it has a small gap as well, and then this is attached to T. Now this scale touch this surface. When this scale touch this surface feel 600. Okay, well, like that. When this scale touch this surface, or this mass of this one touch this surface, so there should be a normal reaction. So then I'll mark this normal reaction as S. So I take bit away, it's usually in the middle, and okay, that's fine. I'll mark as S, and according to the Newton law, that every action has a equal opposite reaction. That's why it has to be S and S. So when you keep the particle on the rod with mg, so you mark this R, but usually we don't mark on the surface. But I told that with my first discussion somewhere, so there should be R on the surface as well. We don't disregard because we are interested on this particle. Actually, this scale will feel something like this. So these two together. So these two together, this is S and this is S. That's how this scale will feel. And this is T. So he feel that the 600G is on the 600G is on the scale. So we leave it. And we know that now the weight of this one is acting on downward to middle. So if I draw it like this, so S is here going in the middle. The weight is going to be, that is 400, 600G. 600G. Now you can see that this 400G also touch with 600G. Then there should be another normal reaction. Then that one, so I'll make a bit length here. So that one is, I'll keep the gap R or any other symbol. So then there should be another R on this one, because according to the Newton law, every action has opposite equal reaction. And also on this one, the weight should be there, 400G. If I draw here, so R is here, 400G down from the middle. So, so on this one, there is another R here. So this is X and this is R. I draw this one again. So this is S and this is the normal reaction for this surface, since this is touch S, and this is the weight of this one, 600 gram. And so 400 and 600 touching here, because that is the normal reaction, R and R, and this is the 400G is the weight of this one. In this one, in this sum, actually this is accelerating to this direction with 0.5 ms minus 1, ms minus 2. But first of all, I consider without acceleration to give a taste of it. Now this is T. If we fix a scale to here, so this scale should feel the value of 600 plus 400, 1000 grams. So the T value should be 1000 grams. So we'll work out for that first. So under one condition, assume A equals 0. It is stable, it is hanging, and the score, we know that when hang on this two weight 400 and 600, it should give the tension is 1000. So this is the general sense. So we'll work with the equation now. So consider F equal MA to 400 grams. Let's say upward. So okay, consider 400 grams. So if we equal MA to upward. So what you can see here, you can see upward R is there, then downward 400 G, and M is 400 times A is what now? It is not going here and there. So assume A is 0, so this is 0. So R minus 400 G equals 0. So that is one equation. Now we'll consider this one. Consider 600 grams. So F equal MA when you put up here. So you can see S is upward. So I will write that is positive 1. And you can see R downward, so negative R, and 600 also downward, that is 600 G times, so that is M, mass is 600 times A is 0, still it's not moving, so I'm under this assumption. So this is not the exactly example 12, I'll just change bit. And so then this is going to be S minus R minus 600 grams is 0. So this is the equation. Now, the other one, consider scale. When you consider scale, what you get? So this is the scale. T minus F equal MA to this direction. T minus S equal, actually M is, we get the light string. If you want to put, you can put M or anything. Okay, we'll tell that M is M times acceleration is 0. So because of that, we get T minus S equal 0. Now, this is 3. So now 1 plus 2 plus 3, what do you get now? When you get 1 and 2, you can see R is cancelling out. And then when you add S, you can see S also cancelling out. So I will add and show you R minus 400 grams plus S minus R minus 600 degree plus T minus S equals 0. Because all zeros. Now you can see minus R plus R cancel out. So this is minus S plus S cancel out. So this is, you can see minus 1000 G equal plus T equals 0, T equal 1000 G. That's true, right? So when you have the scale should give the 1000 G. Now I can put F equal MA to whole system. So for whole system, when I consider whole system, what will happen? These are cancelling out. R and R disregard. S and S disregard. So this is, it's look like this. So you have, this is 600 G downward. This is 600 mass. So this is 600 G downward. And this is 400 G downward. So if we equal MA when you put up, you can see T minus 600G minus 400G equal, what is the total? 1000. 600 plus the total mass is 600 plus 400,000 times, if it is not moving, it is 0. So then T minus 1000 G equals 0 and T equal 1000 G. So if we want to straight away find only tension, so you should consider whole system, and you can easily we can find the tension. Or you can write separately, and when you add each bar, everything, and then it will cancel out, and you can get you can find tension. So then we should be smart with our experience. Actually, we will get that when you work out lot of sums, you will get it. That if they need to find tension only, then you have to consider whole system and put rather than separately. But if they ask one by one, for example, in this question, find the tension in the string. So we can consider whole system, we can find the tension and find the forces exerted on B by mass A. On mass B by mass A. So this is A and this is B. So then they are asking to find this R value of this one. Then the smart question, find the forces exerted on B by the scale. So then they want to find this S in third one. In that case, you have to consider system by system. Sorry, separately or each particles and the scales. In this sum, I actually work with the gram. So we'll work with the kilogram properly when we work example 12. This is 600G and this is 400G. So this is going to be 1000G. Let's consider example 12 now with the acceleration. So I adjust this rate 0.4, 0.6, 0.4, 0.6. So I work with 400, 600. So that's fine. So now we'll consider whole system, or we'll consider separately. So it has acceleration A equals 0.5 ms minus 2 to upward. Now, so when I consider particle A, particle A is this one. So I have 0.4 G and R upward. So the same thing I draw separate like this. So F equal MA to upward. Then F is, we can see, R minus 0.4 G equal, the weight of this one is 0.4. So 0.4 times A is given upward 0.5. So this is the first equation. Then consider this one, particle B. So you can see that on particle B you have 0.6 G and you also have R on it, and then you all have S on it. The same force I draw differently. So S I'll bring from middle to upward, and so F equal MA to upward. So S minus R minus 0.6 G equal, this weight is 0.6 times A is 0.5. So this is the second equation. and parts and consider scale, then we will get f equal ma to upward. So we have this setup. S is here, T is here, and it is moving with 0.5 ms minus 2. Then T minus S equal, now weight is 0 because it's considered that light scale pan. So why it is 0? Light scale pan times A is 0.5. So this is 3. And this is enough. Now we can work. How many unknowns? R, S, T. 3 unknowns. 3 equation we can solve. And if we consider whole setup like this, consider whole system, F equal ma to upward, then we have T minus 0.4 G minus 0.6 G equal totally 0.4 plus 0.6, that is 1. 1 times acceleration upward is 0. This 1 because 0.4 plus 0.6. So from here you can get the tension straight if you consider whole, or the same answer you will get when you add 1 plus 2 plus 3. You can see R to R cancel out, S to S cancel out, and you will get the same answer. So I will show you if you want. Already done. 1 plus 2 plus 3. So 1 is R minus 0.4 G, and 2 left side is S minus R minus 0.0 G, and this is plus T minus S equal, this is 0.4 times 5, 0.5, plus this is 0.6 times 0.5, and this value is 0. This is equal to 0. So you can see that minus R plus R cancel out, plus S minus S cancel out. So T is here, this is minus 1G plus T equal, this is 0.5, 0.6, factorize 0.5 plus 0.6 times 0.5. So this is become 1. 1 times 0.5 minus G plus T. So you will get the same answer. What is this one? T equal G. So when you simplify this one, T minus G equals 0. So T equal G. So this is also T equal G finally, because sorry, this is not the so not T equal G. So T minus, this is G equal 0.51 times. So this is also minus G plus T equal C 1 times 0.5. So 0.4 plus 0.6, this is 1 times 0.5. So this is T minus D, this is minus G plus T, both same. So what I want to emphasize now here, when you consider, you can get the equation consider whole system, you can get the equation. The same equation you can get when you add those two together, 1 plus 2 plus 3. The first question in this sum, find the tension. So T minus D equal, yeah, that's fine, everything is fine. So the tension equal, we can take here, or when you add these three you get the same equation. So T equal G plus 1 times 0.5, which is 0.5. So G is 9.8 plus 0.5, this is going to be 10.3 Newton. So the second question is part B. Find the force exerted on mass B by mass A. Exerted on mass B. So this is the one by mass A. So mass A give a burden to B. That weight is R. So we know that this is same as this one. We can find from here. So we work the equation R minus 0.4G equals 0.4. So R equal 0.4 times G plus this is going to be 2, 0.4 times 0.5. So when you simplify, you will get the answer 412 Newton. Sorry, 4.12 Newton. It can't be that kind of big number. 4.12 Newton. Yes, this is 2 and this is 9.8 times 0.4. So part B is 4.12 and part A we found out that is 10.3 Newton. And now part C, find the forces exerted on mass B by the scale pan. So we can take in two ways. One is this one. So SCC in this equation R we found out already 4.12 and we can find S. Or the simple one is this one. So this is equal to 0 because there is no weight on this one. Because of that, T equals C from here. Tension equal S. So OS equal tension. So do we know tension? Yes, we found out tension is 10.3 here from this. So hence this is going to be 10.3 Newton. That's all, basically only one thing. So sometimes they may draw in this form. So this is R and this is 0.4 G weight. So they will draw in like this, R upward and 0.G. So that is fine. And they both should be in one line. And then this is also same. S is upward, R downward, and 0.6 also in the same one. So 0.6 G. This is R and this is upward. If it is not in the same direction, same line, so what will happen? It will give a rotational force. Like a closing a tap, you will get the rotational force. So something like that. If this is a particle, if S is working in here and R is working here, so this is unbalanced, then this has to be rotate. So it will rotate until this SR and align. So basically when it's come to here, R here, S here, now it is in one line, then it is settled. Rotation is stopped. Also sometimes you may get some sums with, now this is, we consider that the scale weight is 0. That's why this is become 0 here. So sometimes you may get scale weight as well. So that's only different. So in that case, it will add another capital MG to here. That's all. Let's discuss exercise 10E now.